Alright, imagine this. You have launched your beautiful little Next.js application. It's fast, sleek, looks beautiful, but here's the kicker. Under the hood, it's an open invitation to hackers. Yes, you heard right. Hackers. Whether it's exposing sensitive data, allowing your website to be scraped by bots, or even leaving your website vulnerable to cross-site scripting. These are the kind of security issues which can turn your website from your little dream to an actual nightmare. But don't worry, in this free video I will break down the most common security mistakes I see developers like you make in their applications. And most importantly, of course, I will show you how to fix these issues. And with that out of the way, I think it's time to see what issues your application has and how you can fix them. So let's roll the video. Let's go! Alright, let's get started with security issue number 1, and this deals with server actions. So before I show you the issue, let's first of all look at this example. So right here we have a form to create a new task. So we can give it a task name like homework, and then we can pass a user email for some sort of security reason. Then I can create a task, we have a pending state right here, and then at the bottom we see our task with the task number and then the actual task. The code behind this magic is relatively simple. So we can go to the page.tsx. Right here we first of all fetch data from Prisma. This means I fetch my tasks. And then at the bottom I map over them, I render the index, the ID, and then the task name. Above this div we have a card. And then in the card I have a form component. This form component is an external component. Inside of here we have a form, and in the form we have two inputs for the name and the email, and then at the bottom we have a submit button. And then also for the form you see I pass a action. So let's open the actions file, and inside of here you see a server action called create task. I mark this as use server because at the end of the day this should be a server action, not some sort of client action. And then in the params I get my form data, and then I do the mutation with Prisma. I pass my name and my email using form data, and then I return revalidate path, which means I just revalidate my index page to get my new task at the bottom. So the code is relatively simple. And now you might ask me, hey Jan, what's the issue with this code? Because at the end of the day, this is probably the code which you write every day. Well, the problem is that Next.js, this means when you use a server action, Next.js creates a public endpoint. This is something that most people don't know. So if you go to the documentation, at the bottom, right here you see I'm right at the bottom, they mention by default when a server action is created and exported, it creates a public HTTP endpoint and should be treated with the same security assumptions and authorization checks. Now you might say, hey Jan, show me the actual public endpoint. Well, let's go to the inspector, let's go to the network tab, and then let's create a task. So homework, let's pass an email, and then let's click on create task. And what do we see right here? Is this an actual request? Yes, it is. So as you see, we did a request to the index page. This is a post request. And then if you scroll a bit to the bottom, you also have a next action ID. And in theory, I could copy this next action ID, go to Postman, create a post request, and if I'm a malicious user, then I would be able to submit this form without even being authenticated or actually even opening this website. And this is where the actual problem is. Because if you open the actions file, you see I don't do any authorization. And this means if the hacker at the end of the day wants to do a post request, the hacker can do that. And that's not something I want to allow this person, this hacker, to do. So how can we prevent that? Well, it's relatively simple. Right here we can check that the user or the hacker is actually first of all authenticated. So what I'm doing right here is first of all getting the user session, and if I don't have a valid session, then I just redirect the user to the login route. And we can actually test this out. If I save this and go back and again create a new task right here, you'll see this won't work. We got redirected to the login route, and right here it says you are not logged in. And that's the same for our hacker. If the hacker again goes to the inspector, gets the action ID and then uses Postman to create a request, the user, the hacker, won't be able to actually do this request, because we will right here check, is the user authenticated? We will see that the user is not authenticated, and we will redirect the user to the login route. So now we have fixed one security issue. So we now make sure that the user is authenticated, which means no external users are able to do right here a post request. But now there's another security issue, and that's that we don't validate the actual form data. So instead of passing a string name, a hacker could pass a script, and with that, the hacker could try to do a XSS attack or some sort of SQL injection. So what we want to do in the back end, in the server action, is check, or at the end of the day, is compare our form data against some sort of schema to see that the data which is provided by our form data is actually correct and what we expect. So to do that, what we can do is use Zod. Zod is a TypeScript schema validation library. This means we can create a schema and we can say what we want to get. We want to get an email and we want to get a name. Both of these types should be of type string, name should be a minimum character length of 3, and email should be of type email. And now I can use the schema and validate my form data against this actual Zod schema. So underneath our if user check, we could right here say, hey, let's validate our fields against our schema. So we can import that from our Zod schema file. Then we can do a save pass method. We can get our email and name, and we will pass our form data for the values. And now Zod right here will compare our form data, which we get, against our Zod schema. And if this email is not of type email and string, then we will return right here an error. So now we make sure that our form data is sanitized and that the form data is clean, so that no user is trying to do some sort of XSS attack, SQL injection, or something malicious. And now if we save this, you will see the code still works fine, or in other words the website. But now let's create a task, and instead of passing an email, I will pass a script, and inside of here I will pass a alert and just say something like hacker. If I now click on create task, you'll see at the bottom we haven't created the task. Why is that? Well, that's because we do a if check right here, and if this validate fields.success is not true, we return a error message. This means I can go to my form component and I can get the error message inside of here. So now I get my message, which means underneath this div, I can just pass a p tag, or we can say, hey, if we get the state.message, then let's return it. And if I now save this and go back, we can right here again pass a script. I can now click on create task, and now you will see some fields are not filled out. So this is this if statement in effect. So now we make sure that first of all the user is authenticated. This means no outside user is able to submit the form, but we also make sure that our form data is clean and sanitized. But now we have security issue number 3. And what is this issue? Well, let's look at this submission. We have a task name and then we have our user email. But this user email does not look correct. It looks like a fake email. And if the user provides a fake email, we don't want to allow this user to create a new task. Because if I right now click on create task, we have our pending state. And then at the bottom, you see this is a fake email task. Ha 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 ha. Is that what you want to do? Is that something that you want to allow the user to do? Probably not. So this is where the sponsor of this video comes into play. ArcChat. ArcChat is a service which I have been already using long before they even reached out to me, and this is also a service which I have been recommending in the comments way before they have reached out. But what even is ArcChat? Well, ArcChat is a security platform. This means they help you with bot detection, rate limiting, email validation, that's what we want to do, attack protection, data redaction, and at the end of the day, it's a developer-first approach to security. And I know security is often a pain point, but ArcChat takes the pain point and makes it super simple. So what you can do right now is head over to the YouTube description, click on the first link, and then we can get started with integrating ArcJet into our application. So let's go to the documentation. Let's go to the Next.js SDK reference. We want to get the package. So let's first of all install it. And then once the package is installed, we can first of all restart our dev server. Then let's go back to the dashboard of ArcJet. Inside of here, we can get the API key or the ArcJet key. Let's copy it. Let's open the env file. Let's paste it. And now we can implement ArcJet. So if I go to the documentation, the next step is to set up a single instance. And this is because the SDK caches decisions and configuration to improve performance. And at the end of the day, we want to all have better performance. So what I've done is already set up this single instance. So in the utils folder, I've created a ArcJet file. Inside of here, we first of all import all of the actual primitives or rules because again, as mentioned, ArcJet offers a lot of features, like for example, rate limiting, bot detection, email validation, and more. And that's what we import right here. Detect bot, this is a primitive. Shield is a primitive, and validate email. That's what we want to use. Then we re-export it right here and we create our base ArcJet instance. We pass our API key and we have an empty rules array. And inside of here, we can add our rules. So we can close our ArcJet file. Let's go into our server action. And inside of here, I want to now validate our email. So what we can do right here is first of all call our ArcJet base instance, and then we can use the with rule method. And in this with rule method, I can pass all of the primitives which I want to use. And I want to use validate email because I want to validate the email and see if it's a real email. So for the mode, we use live. This means we will actually block the request if it's a fake email. And right here we have our blocking criteria. This is an array. And we say, hey, we want to block the email if it's a disposable email, if it's invalid, and if there are no MX records present. So now we have right here our constant AJ. And this AJ, this is short for ArcJet, will have two responses. Either it will say, hey, the email is correct, or it could say, hey, it's incorrect. But before we get the actual decision, we first of all have to check our email. So we can do a constant decision equals to await aj.protect. We want to pass a request object and then a email. For the request, I can also get it. We can do a constant request equals to await request, which is imported from ArcJet. So now we get our request, and now the decision which we get from here is either true or false. This means either this right here request is allowed or it's denied because the email is fake. So we can do an if check and say, hey, if the decision is denied because the email is not valid, fake, something like that, then let's return a message and let's say, hey, email is not valid. And now let's go back and let's again test it out. Let's get a fake email. Let's again say fake email, ha ha ha. Let's create the task and email is not valid. What the hell did just happen? Well, ArcJet right here got the email, it checked its database and it saw, hey, this email is not real, it's a fake email. Let's block the request. So we did an if check and right here it decided that it's a fake email, so we returned email is not valid. We can also go into the ArcJet dashboard and inside of here you see deny. And the reason for that is that first of all the email type is disposable and that the email type has no MX records. Did you see how easy that was? We created a base instance, then we just said, hey, I want to use this rule right here. I want to validate the email. We said that we want to use mode live and we said what we want to block. Then we just called it. We right here check the decision. If it's denied, then we just return an error message. But you know what? Let's also see if real emails are not filtered out. So for the task name, real email, for the user email, my personal email, and let's create the task. Let's see at the bottom, real email. And if you go to the dashboard, you see right here, allow. And this is because the email is a real email and this is my personal email. Please don't write me any emails. Thank you. Alright, let's now continue with issue number 4. And this issue deals with leaking secrets to the client side, which you want to never do. Let me show you the example. So we are in the example 2 folder. We have a page.tsx. This is a standard server component. We have a export default function and we just return a card as you see right here. nothing groundbreaking. In the same folder, we have a loader file. And this is an async function which we export, and inside of here we have a variable which we actually create inside of this function. So constant test and then super secret don't leak. Now this isn't a problem at the moment, because if I go inside of the page.tsx, in theory I can also get the function inside of here. So we could do a constant secret equals to get secret, that's fine, this isn't a problem, but this is not a problem because this is a server component. This means if I go back right here, nothing is wrong. I don't leak anything to the client side, and that's again because we are in a server component. We are in a server environment. But now let's imagine the following happens. A new developer comes into our code base and right here wants to mark this file as use client. And now we have an issue, because if I go back, you don't see anything in the HTML, that's fine. But if you go to the inspector, you can actually go right here to our sources. Then in the sources, we can go to next static, to the chunks, to the app, example2, page.js, and then right here I can search for the secret. And what do we have right here? Constant test, super secret, damn don't leak. Is this the secret which I didn't want to leak? Yes, it is. And that's not what you want to do. As you just saw, this file is on the server side, or at least this file should only be invoked from the server side. But now I made a little mistake where I marked this file as use client, and tada, we just leaked a secret. And that's not what we want to do. So how can we fix this? Well, there's one fix, and this is that we want to say, hey, this code should only run on the server side. How do we do that? Well, we can do a import server only. And server only is already installed when you create a new Next.js project. And if you now go back, you see, failed to compile. You're importing a component that needs server only, and this only works in a server component. But because this page.tsx, the parent, is marked as use client, we get an error. One thing which I want to also mention right here is that a lot of people confuse server only with use server. Server only means that the code, which is right here, should only run on the server side. Use server is that you initialize a server action. Two different things. But we're still not finished right here. So now we have server only, but this means that this code can only run on the server side. But what is if we want to actually allow the user to run this code on the client side, but at the same time we don't want to leak our secret? Well, what we will do is actually create a new environment variable. So now we have our super secret damn don't leak. We can copy the name, let's go to the loader, and instead of this, we can get our process.env and then .supersecret damn don't leak. And now let's again test it out. So let me delete this import server only. Let's save it. Let's go back. Let's go to the actual inspector, to our sources, and let's search for it. And what do we see right here? We have our constant test, this one right here, but you don't see the secret. And that's because the secret is in a environment variable, and a environment variable is never leaked to the client side. It's always on the server side. So now we understand how we can prevent secrets from being leaked to the client side. So that's one more issue out of our project. Let's now continue with example 3 and issue number 5. And right here we have a button to generate a PDF. If I click on the button, we will get redirected to an actual API route, and inside of here, I generate a new invoice. The code for that is relatively simple. We have a example 3 folder, a page.tsx. Inside of here, we have a link, and this link redirects to an API route. Let's open the API route. Inside of here, we have the PDF folder, the route.ts, and all I do inside of here is first of all initialize a new GET request, so our route handler, and inside of here, we generate a new PDF. And you know, right now, there's nothing wrong with this code. But let me show you something. Right now, we are in my terminal, and inside of here, I have created a lot of curl commands which try to do a GET request to this actual route. And if I click on enter, you see everything worked on my end. And if I open my terminal for the project, you see get API PDF, and this is like 10 times. You see where the problem is? If a malicious user comes, he could create 1 million requests to this API route, and I would generate this actual invoice 1 million times. And the problem with that is generating an invoice is resource intensive, which means this would cost a lot of money, and that's not something which I want to spend. So how can we prevent something like this? Well, it's relatively simple. We can implement rate limiting. And to implement rate limiting, we can use again argjet. So we can first of all again initialize argjet right here. We can get it from our utils file. We can use the with rule method. And in the with rule method, I can actually right here pass what I want to do. Or in other words, what I want to protect. And we want to use rate limiting. And for rate limiting, there are a few algorithms, and one of the algorithms is fixed window. This means in a window of 60 seconds, we can have a maximum of 10 requests. And let me show you how this works. So we can again go right here in our async function. Above the constant PDF, we can again do a constant decision, and this will be equal to await aj.protect. So again, we get our aj right here, and then we call the protect method, we pass our request. And as you all know, this decision could now either be denied or it could be allowed. So let's see. Let's do an if check and let's say, hey, if the decision is denied, this means if there are too many requests, let's just return a error message right here. And again, we use the fixed window algorithm, which means we can do a maximum of 10 requests in 60 seconds. Let's go back. Let's do a hard refresh. As you see, everything works. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now, error. Too many requests. And if we go into the argjet dashboard, we also see an error right here. It says deny, and the reason is rate limiting. Now, as I mentioned, argjet offers a few algorithms like fixed window. This is the most basic and the most common one. So you have a window and then a maximum amount of requests. And right here you see then if the client exceeds the limit, they are blocked until the window expires. And that's what we have. Another algorithm is the sliding window. And this algorithm tracks the number of requests made by a client over a sliding window. This is a more complex algorithm, but also relatively interesting. And then one of my favorite algorithms is the token bucket. And this algorithm is based on a bucket filled with a specific number of tokens. But now let's again go back to our example. Right here we have a rate limit of 10. But what is if we want to make the rate limit dynamic? This means if the user is authenticated, we want to have a rate limit of 10, and if the user is not authenticated, we want to have a rate limit of 2, for example. So now I've created a new function, getClient. Inside of here we get a session, and the session is a boolean. If we have a session, we then create a maximum amount of requests of 10. But if the user is not authenticated and does not have a valid session, we give it a maximum amount of requests of 2. And then in our code, we first of all get our user session, and then we can do a constant decision. We call getClient, we pass our user these 2 exclamation marks. At the end of the day, get the boolean, so either we have a session or not. And then we call the protect method and we pass the request. If I now save this and go back, you'll see that I'm authenticated. This means I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 requests. But after 10 requests, you see maximum 10, remaining 0. But if I copy the URL and open it in a new incognito tab, you'll see I can do 2 requests. So let's do a hard refresh. You see 1 invoice. Let's again do a hard refresh. We have a second invoice. But if I again refresh the route, we see too many requests. Rate limit, maximum of 2, remaining 0. And if you go into the argjet dashboard right here at the top, you see we again got denied, and the reason for that is our rate limit, and we have a maximum of 2. So now we have created dynamic rate limiting. This means if the user is not authenticated, then we have a maximum of 2. But if the user is authenticated, we have a maximum of 10. But you know what? There's still one problem. We now rate limit this specific API route, but we still allow bots to scrape this API route. Because again, if you remember, I right here created a curl statement, and with the curl statement, I could actually do a request to this route. Is this something which I want to allow? No, that's not something which I want to allow. And now we can actually prevent that. So for that, again, argjet has our back. And what we can do right here is use detect bot. This is another rule provided by argjet. We say right here mode of live. This means we will block requests. And then we also have an allow array. And inside of here, we pass all of the actual bots which are good bots. This means bots which crawl your website because they are a search engine and you want to be indexed. This means if I now save this and go back, everything still works as you see right here. But if I copy the URL and do a curl statement and click on enter, you will see we get an error. And the reason right here is reason type bot. So as you see, we don't allow any curl requests anymore. And if I go to the dashboard, again, we have an error. And right here, the reason is that we have a bot. And the exact bot is curl. Of course, you can also allow curl if this is something which you want to do. So we could say curl, and if I again save this and do another curl request, you will see this will work. And if I go to the dashboard right here, we also won't get any deny because I allow a curl request to happen on this API route. Okay, so now we have talked about quite a few security issues, but we are still not finished. Another issue is relatively trivial, and the issue is called trivial packages. What's exactly the problem? Well, if you use packages like most of us do, there's always a risk, but trivial packages create a big risk. So right here, for example, in March of 2016, the widely common and used JS compiler, Babel, was broken by a sole individual, by one person. The package used by tech giants such as Facebook, PayPal and more was not brought down by a malicious hacker, no, but rather due to the removal of the leftpad module within the NPM registry that Babel relied on. And the interesting thing is, this module was only 11 lines of code. 11 lines. So what exactly is a trivial package? Well, a trivial package is a package with under 35 lines of code. Right here, we have 11 lines of code. And as you see, Babel, a compiler used by pretty much everything, was exploited with only one package and 11 lines of code. And you know what? There are two interesting packages. This is isOdd and isEven. So isOdd just returns true if the number is odd. Is-even returns true if the number is even. Now look at the weekly downloads. Is-even has 150,000 downloads per week. Is-odd has 300,000 downloads per week. So these are in total almost 500,000 downloads per week for something so basic. And you know what's funny? There's actually a reminder operator. This is this percentage symbol, and this actually allows you to know if the number is even or odd. So people use trivial packages even though the code to actually create the same result is super simple. And this is a big problem. Why is this a problem? Because at the end of the day, you rely on one small package which you could write yourself, or you could write the code yourself. And what is if this package is deleted? Or what is if a maintainer creates malicious code in this package? What is if this package gets hijacked? You rely on this code, you don't really check the code, but at the end of the day, you have severe vulnerabilities in your own project and you didn't even write the code. So what is my recommendation? Well, if the code is trivial, if the code is really simple to write with only one line, with one operator, then why the hell do you install a package and create such an security risk? Packages should be seen as something like, hey, this is external and I should only install it if I really need it. But if it's trivial and you can write it with one line of code, why the hell should you do something like that and create so many security and compliance issues? Okay, so now we understand that trivial packages are something that you probably shouldn't install and something which you should probably just create yourself because it's relatively simple. But we have another issue with this project. So this is example 4. And in example 4, I can create a blog article. So right here, we could create some HTML and then just create the blog. Then at the bottom, you would see object. But here comes the issue. If you go to the code right here, you will see we first of all fetch the data, then we have the form, we have a server action, nothing groundbreaking. But then when we map over the data, we do a dangerously set inner HTML. And this dangerously should probably already say everything. What we do with that is that we just take the content, which we have created right here, and we just paste it as HTML inside of here. And this skips the sanitation step from React. And this makes you vulnerable to XSS attacks, so cross-site scripting. What exactly is cross-site scripting? So as an example, right here in the blog content, the user can right here create HTML, then an H2 element and stuff like that. But what the user can also create is a script tag. And in the script tag, the user could say, hey, let's do a fetch and I want to, get the bank details and stuff like that. This is cross-site scripting. So what happens is that this attacker at the end of the day creates this little blog article with this malicious script. The user opens the website, it's a legitimate website, but at the same time, this website executes the malicious script. And with this malicious script, we for example get the bank details, we install some sort of weird software or something like that. And then at the end of the day, the attacker gets our private data, the IP address, our passwords, stuff like that. And that's not what we want to allow. So how can we prevent a XSS attack? Well, it's relatively simple. Don't use dangerously set inner HTML. The name already says enough. Dangerous. Forget it. Instead of doing that, either use the package provided by your rich text editor to sanitize the content, or if you are able to, render the actual code, the actual content, in your code, because you don't want to skip the sanitation step of React. You don't want to make yourself vulnerable to such attacks, because at the end of the day, once you create such a vulnerability, it's very easy for an attacker to create a script and to execute this script on the website. Alright friends, we are almost finished with this video. There's one more thing which I want to mention, and that's that ArcJet actually offers a feature called Shield. And ArcJet Shield protects your application against common attacks, including the OWASP top 10. So if you didn't know, OWASP stands for the top 10 web application security risks. And right here they show you what the top 10 risks are. Like for example, broken access control, injection, insecure design, server-side request forgery, XSS attacks, and much more. And to implement ArcJet Shield, it's relatively simple. What I would do is actually create a middleware file, and then in the middleware file, you can right here run Shield. And ArcJet Shield again protects you against the most common attacks. And right here, they actually have a documentation on what exactly they block. So for example, SQL injection, cross-site scripting, PHP code injection, HTTP proxy, and much more. So at the end of the day, Shield adds an extra security layer in the middleware file, and you don't even have to do anything. And middleware runs before your request. So if ArcJet already sees, hey, there's someone trying to attack the website, then ArcJet can block this request, and we don't even have to execute any code. And this is super cool. And yeah, now we are finished with this video. I hope you guys could learn a lot. We looked at a lot of issues, a lot of examples. Thank you ArcJet for making this video possible. Definitely check out ArcJet with the first link in the YouTube description. They are one of my favorite services, and I actually use ArcJet in my own personal projects. And now with all of this out of the way, I hope I can see you in the next video. Enjoy your day and bye!